Hello everyone and welcome to We Are Learners. So the topic that we'll be covering today is number system power revision 1. We'll be having multiple sessions based on this, as many of you have requested that power revision is something that you need for this particular topic. This is actually for grade 9 CBSE. In case if you're new to the session, please do subscribe the channel, do comment, like, share, right? And you can also state your favorite topic, right, in the comment section in case if you want a video on that. So this is how our roadmap is structured. We'll be having introduction part, and then we'll see rational numbers, irrational numbers, and then we'll be defining real numbers, and we'll be having some decimal expansions as well in our consideration. Let us have this started. So the first, I hope my slides are visible, right, people? Okay, so the first and the foremost thing that we'll be covering here is number system. Under this, we'll be covering natural numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers. So I'll be, giving you a recapitulation of whatever you have studied in previous grades or lower grades, and then we'll be, having new topics discussed in this particular session. So let us jump to OneNote. Allow me a moment. Let me share my OneNote screen. Yeah. Okay, so I hope it is visible. Yeah. All right, so the first topic that we had was natural number. Generally, the denotation of natural number is capital N, and these are the numbers getting started from 1, 2, and they are going till infinity. So in order to denote something going towards infinity, I'll be using 3 dots. Then the next topic was whole number. So we can say that whole number is the biggest class. Why is that so? Because it has 0 also in it, right? Along with the counting numbers. Natural numbers are also known as counting numbers, right? So whatever these numbers are, if we append a 0 at the very beginning, then this particular set becomes whole number, right? And they are also going towards infinity. Why do we need whole number? Many a times, if you see a practical observation, right, we have ground 0. Ground 0 is representing what? The lower ground, right? Negative is denoting what? The basement. Suppose if you are actually visiting any mall or any movie complex, right? So the negative one denotes the basement where you are parking your vehicles. Fine. And above it we have 0th floor. 0th floor is the base, where you will be having different counters for ticket booking, or if it is a mall, then we'll be having grocery shops, right? And we'll be having pharmaceuticals, right? The shops where the senior citizens can approach. So that is 0th floor. First floor is something that involves some physical or muscular exercises, right? In order to move to first floor, if the escalator is not working, or suppose if the lift is not working. So that is an exception, right? With respect to apartments I'm talking about. So that is why we need whole number into picture. Third topic was integers. See, capital W is the denotation of whole number. Capital N is the denotation for natural number. Integers, they are denoted by I. So let us consider one example. Suppose we have a number line, right? It is a line, that is why it is extending in both the directions, right? Here we have positive numbers, and here we have negative numbers. As this is a line, that means negative sequence is also continuing, and positive sequence is also continuing. So if we have negative numbers and positive numbers along with 0 in it, 0 is neither negative nor positive, so this particular set is known as integers, right? Positive, negative along with 0. Coming to the very important topic, and the topic that we'll be studying today is rational numbers. The denotation is Q, right, people? So let us jump back to our slides and let us see what the slides are stating. I hope the slides are visible. So rational number, the denotation is Q, right? So let us discuss them, what rational numbers are and how we can have other set classifications, right? Now suppose if we have anything in this format, P over Q format, right? Where Q does not equals to 0. Now many of you will comment, sir, this is something that we have already studied in fractions, right? Then why we are calling this as rational number? So I'll be, figuring out the difference between rational numbers and fractions in a while. If something is given to you in this format, however, numerator can be 0. See, this is the numerator. And this is the denominator. Right? Denominator cannot be 0. If that is the case, then we have a situation wherein, the number is not defined. I'll be giving you a separate video on this, and I'll tell you why the number is not defined, how we can, attain that. So we'll be having a separate video, short video on that. Fine. So denominator cannot be 0. This is something that is we understood, and we'll be, taking this for granted. It should not be 0. Otherwise, the number is not defined. While numerator can be 0, right? 0 by any number is 0. Fine. So P by Q is something that you have already gone through with, right? In fractions, then how it is different from rational numbers. So in case of fractions, people, this P can be a whole number, right? And Q will always be a natural number. Why is that so? Because natural numbers are getting started from 1, 2, 3, right? As I told you that Q cannot be 0. So why we are considering this? Because in terms of, if we are talking about fractions, then they are always positive, right? So all fractions are rational numbers, but not all rational numbers are fractions. Rational numbers can be negative as well. Then many of you will have a question, sir, we have subtracted fractions, right? We have done this. 1 over 4 minus 1 by 2. This is something that we have done, right? Then what does this represent? Okay, this is something wrong. I've written it in a different way. So it should be 1 over 2 minus, let us say, 1 by 4. All right. So if you want to subtract this, obviously biggest part will come first, and then we'll be having the second part. However, if we are considering rational numbers, then we can, change the order. If you calculate this, this will be 2 over 4 minus 1 over 4. That is nothing but 1 by 4. Right? But if you consider this, then this will be 1 over 4 minus 2 by 4. So it will be minus 1 by 4. So here we are getting a negative answer. Negative answer is representing, again, it is representing P over Q form, but we cannot call this as a fraction because this is something different. This number is a rational number. So rational number is, is in P by Q form, and fractions are also in P by Q form, but fractions are always positive. Fine. However, if you want to comment on this, that means we are removing something. Now consider an example. If you would have been given with a pizza, right? It contains 6 slices. So if you are removing 2 out of it, so that is nothing but a subtraction. So you can think it practically in that way. While coming to a different scenario, then rational numbers are needed, because if we are, performing any calculation, and by chance if we come up with a negative number which is in P over Q form, then where do we, actually be putting it, right? So in order to have that classification, we have rational numbers. So rational numbers can be negative as well. All right. So that means P over Q form is something that is needed. Q does not equal to 0. P can be any integer, and Q can also be any integer, while Q cannot be 0. This is something that is a case. So it can be I minus 0. Otherwise, any other number we can have. We can write it in this way. All right. Sets are represented in curly brackets. Set is a what? Set is a collection of well-defined objects. Now, what do we understand by well-defined objects? That means it must be universally accepted, right? Natural numbers, counting numbers are universally accepted. For me, the face value of 5 will remain the same as compared to, the person who is there in USA, comparing the same with something, right? And taking 5 as one such number. So the face value remains the same. Fine. Then let us jump back to the slide, and let us see what the slide is stating. All right. Irrational numbers are what? Irrational numbers are the numbers that cannot be expressed in P over Q form, right? So for example, we can take an example into our consideration, root 2. Few of you can comment, sir, root 2 can be written like this, root 2 by 1. So I'll tell you the story behind root 2. If you actually, calculate the value of root 2, then it will be something 1.414, something like this. So it is non-terminating and non-repeating. So if this is the case wherein we are getting non-terminating and non-repeating, right, then we say that yes, the number is actually an irrational number. So I'll be giving you an example of this terminating, non-terminating, right? That will be there in a while. Allow me a moment. All right. So real numbers are what? They are the combination of rational numbers and irrational numbers. Fine. So if we have rational numbers plus irrational numbers, then we have real numbers, right? Next is decimals. Yes. So I told you that I'll be discussing terminating, non-terminating, and I'll also let you know how to solve this type of questions, right? 0.6 bar and 0.237 bar. All right. Chalo, so let us get this started. Allow me a moment. Let me share my screen again. OneNote screen. I hope it is visible. All right. So suppose if we have a number 1/2, if you go with actual division, division is not possible, right? You need to insert a dot, 0. 5 times 10, the remainder comes out to be 0. Fine. Now this is the quotient. Quotient is actually terminated, right? It is not getting repeated, or it is not getting, into any loop. It gets terminated. So we can say the answer to this is what? Terminating one, right? So it is terminating in nature. So this is one such classification of a decimal. Consider another example, 1/3. Now, if we actually divide 1 by 3, then what will be getting? So I'll give you 30 seconds to think. It will be 0.333, something like this, right? And it will get this 333 is getting repeated in an infinite loop, right? So how are we getting 0.333? Let us have a look here. This is the actual representation of 1/3. Division is not allowed, so it will be 10. 3 times 9, we have 1 again. 0 is to be appended. 3 times 9, we have 1 again. 0 is to be appended. We have 3 times 9, 1 again, right? 0 is to be appended. 3, 9, 1, 0 is to be appended. So every time we are getting 10, 10, 9, 10, 9, 10, 9, something like this. And this is not getting stopped, right? That means this is getting repeated. So we can say that 1/3 is actually repeating, right? And the repetitive digit is 3. So I'll be putting a bar over it. It represents what? That 3 is getting repeated in an infinite loop. All right. So this is something that is not terminating. Now it is not terminating. Sorry. Simultaneously, it is a rational number, because if you express 0.3 bar in P/Q form, then this will be 1/3. Already, I have already written this. I'll also be guiding you how to convert something into P/Q form. If it is non-terminating plus repeating. So if this is the case, then we'll be classifying a particular number in rational category. While irrational numbers are non-terminating and non-repeating, right? All right, so let's get this started. Suppose if 0.6 bar is given to you and somebody is asking you to represent this in P/Q format, how will you be representing it? So step number 1 is to assume it to be equal to X, right? And instead of this bar, we should be writing it as 666 3 dots, right? That means it is going towards infinity. Call this as equation number 1. Now, this is step number 1. In step number 2, you should be multiplying equation 1 with 10. So if you multiply equation number 1 with 10, you'll be having 10x here. LHS will be 10x. And if you multiply this particular thing with 10, it will become 6.6663 dots. Sir, if you multiply 0.666 by 10, then you will be having 6.66, right? But I told you that this is going towards infinity. So we can, borrow another 6 from this particular phase, right? So that is why we have 6 4s here in step number 2. Call this as equation number 2. Now, obviously, we need to subtract. Whenever we have two equations, we prefer usually, elimination method. All right. In case if you have not gone through with elimination method, then we already have one video on linear equations in two variables, right? Then there I have discussed the elimination method. You can go through with that, although it is not there in 9th grade. So that means we need to have first subtracted from second. So this is step number 3. So I'll be writing it in a more synchronized way so that it will look attractive for you while revising. 10x equals 6.6663 dots x equals 0.6663 dots. So our sole agenda is to have these digits as same, right? After the decimal point, they should be same, so that if you subtract them, then it is very easy for you to perform the cancellations, right? 6 minus 0 will be what? 6. This will be what? 10x minus 1x will be 9x. Now we get linear equation in one variable. All right. So it will be 9x equals 6. So that means x should be 6 over 9. So this will be 2 over 3. Now you can actually, calculate if you have 2 over 3. Are you getting 0.666? Obviously, right? So this is the P by Q representation of 0.6 bar. Let us jump to our slide, wherein we have another thing to be discussed. Yeah. I hope the slide is visible. So 0.237 bar is something that we need to identify. So let us again move back to, it is 237. I hope I haven't pronounced it incorrect. It is 0.237 bar. Fine. So we are given with yet another example, 0.237 bar. I told you in step number 1, assume it to be equal to x, and you should be expressing it in this way. 3 dots, call this as equation number 1. Now if I'll multiply this with 1000x, right? Equation number 1 by 1000. Why is that so? Because see, my sole objective is to have this 237 in repetitive format. Call this as equation number 2. Obviously, smaller is to be subtracted from the bigger. So 1000x equals 237, 0.237, 237, 3 dots. And this will be x equals 0.237, 237, 3 dots, right? If you subtract them, so this will become 0. 237 minus 0 is 237 equals, this will be 999x. So from this we can say that x should be 237 divided by 999. All right. So this is the representation wherein x is nothing but it is representing a rational number, right? 237 divided by 999. So it will be 237, 237, something like this. Fine. Okay, so let us move to our slides now. Fine, we are done with this. So if you can observe that they are non-terminating, but they are repeating, right? So we can express them in P over Q format. But if they are not repeating, then we cannot express them in P over Q form, and we call them as irrational numbers. Fraction, I told you what is the difference between a fraction and a rational number. Rational numbers are positive, negative, right? While fractions are always positive. Fine. So this marks the completion of this video, although this is the shortest video that we had. But in next video, I'll be giving you an insight how to represent rational numbers on number line, and also we'll be having few identities discussed, and then we'll be seeing rationalization. All right. So this is actually a part of your power revision series. So wait for my next video. Thank you so much. In case if you have enjoyed the video, please do hit the like button, as well as do subscribe the channel. Thank you so much, people. Bye bye. Take care.